Okay, children. Now we will learn about Newton's second law of motion. Isaac Newton is moving in a horse. After some time, the horse stops a while. Newton's second law of motion, it states that rate of change of momentum of an object is directly proportional to the unbalanced force in the direction of the force. So that is called Newton's second law. So I'll explain line by line. First definition is told, line by line now I will explain. Rate of change of momentum. Rate of change of momentum is nothing but mv minus mu by t. What is that? Momentum is nothing but product of mass and velocity. Product of mass and velocity is called as momentum. So now here the momentum is nothing but rate of change of momentum is directly proportional to t. Now you think of one condition. One lorry is just it started moving. Lorry is there. It starts moving, and it very less velocity only it is coming, but it hits a person. What will happen to the person? The person will get injured because it is coming with some velocity. Now if you see a housefly long, very very high velocity it is coming, it comes and hit the same person, will the man fall down? No. So that is nothing but momentum. Actually momentum depends upon mass also, velocity also. So now let us consider the first scenario. So in the first scenario, if you see, the lorry's mass was more but the velocity was less, but yet then the impact on the man was very high. Whereas in the second case, if you see, the housefly's mass is very less. Though the velocity is high, the man is not falling. So the impact depends upon the product of mass and velocity. Now in the same case, lorry is there. The lorry is now coming with very high velocity. So now what happens? Mass is also high, velocity is also high. So the impact on the man will be very high. He may die also. So what is the meaning of momentum? Momentum is nothing but it depends on mass also and velocity also. So product of mass and velocity is called as momentum. Now here what they have told, rate of change of momentum. That is, originally a body has momentum mu. After some time the body now attains a velocity v, so it becomes, momentum becomes mv. So this is changing with the time. So we are writing rate of change of momentum. Okay, now let's read the definition. Is directly proportional. You have learnt in maths last year, directly proportional means when one increases, other increases. When one decreases, other decreases. It is directly proportional. So it is directly proportional. The symbol is this one, directly proportional to the unbalanced force. So unbalanced force I am writing as F. Okay. Now, in the first lesson, there is an equation of motion. See, I didn't take first lesson because that lesson is little tough. So that one, after lockdown, I thought I will take because face to face we can interact. But so there one equation of motion is there. So whenever a body is in motion, there are three equation it obeys. So in that, the first equation is v is equal to u plus at. What is v? Final velocity. Now consider one body. A body is in a ball is there. A ball is now moving with a small velocity. Now suddenly a boy comes and kicks it. Now what happens to the velocity? The velocity increases. So what happens? The velocity from small it becomes greater. So it is accelerated. Even in bike you will tell slowly when you are going, suddenly when speed increases we tell it is accelerated. So acceleration is nothing but change in velocity. So v is equal to u plus at. So we are transposing u that side, it becomes v minus u is equal to at. T also we are transposing that side, it will become v minus u by t is equal to a. Now I will explain you how that first equation has come. We have learned that acceleration definition is what? Change in velocity. What is the acceleration definition? Change in velocity. So change in velocity v minus u by t. So you can take that also into consideration. So now m it is common, so v minus u by t. So we have learned v minus u by t is a. So we are substituting f is directly proportional to mass into acceleration. So this is the simplest form of Newton's second law. So we can tell that the unbalanced force is directly proportional to product of mass and acceleration. That is, when mass increases, force increases. When acceleration increases, force increases. So that is the meaning of directly proportional. This is Newton's second law. Now the horses come. Now the story we will see. Isaac Newton is going on his way. Now what happens we will see. Now the horse starts. On the top of a hill, a boy is trying to move the rock. He takes the energy drink, gets more energy. Now he is pushing the rock. Very naughty boy. Oh God, the rock is going to fall onto the ground. Isaac Newton and the horse is on the way. Now the rock falls down. Now the horse is unable to move because the path is blocked. Now Isaac Newton tries to move the rock. Oh, he is so much exhausted. Force applied by Newton causes the rock to move only slightly. Now he challenges the horse. Hey, why can't you try to move the rock? The horse accepts the challenge. Now the horse applies its full energy. The force applied by the horse causes the rock to move at a greater distance. Newton applies less force, less acceleration is produced. Horse applies more force, more acceleration is produced. So F is directly proportional to A, acceleration. Okay, we have derived one part of it. Now they both are quarreling, Newton and horse. How this can happen? Now the boy is analyzing the situation. Now he is able to easily move Newton. So what can we understand? Mass of the Newton is less. So applied force is also less. Now the boy is applying more force to pull the horse. More mass, more force is needed. Mass of horse is more, applied force is also more. So force is directly proportional to mass. Now we will combine both the cases. First one we understood force is directly proportional to mass, and in the first scenario we have understood force is directly proportional to acceleration. So we conclude force is directly proportional to m